Hi, this video is to show the DiffFit demo usage scenario 3. Identify unknown densities from a library of many structures. We will follow the documentation here. So the whole process is very similar to scenario 2, composite multiple structures, only that the input files are different, meaning with one input CorelEM volume map and a folder containing many, it can be tens, hundreds, thousands of structures. So here is we will show a quick demo search from 3 structures, and then later we will do a to show how to search from like hundreds of structures. All the necessary files are at this repository in this folder. You can access it from this link, or you can go to the home page of this repository and click the develop data input domain fit demo 3 domains. And I would like to mention that the volume map file density2.mrc, this file is from the domain fit repository, and the subunit, the candidate files that we are searching from, is also generated by following the domain fit guide shown in this link. So we will use this volume map file and the candidates here to perform the search. And to download it, you can download the whole repository as a zip file, and then unzip it, extract all here, and we have camera X open, and we have launched the DiffFit by tools volume data DiffFit. So now we have DiffFit here, and let's navigate to the data. It is here, and the MRC has already been simulated from these structures. If you have some structures that you need to simulate the map from the structure, you can use this functionality under utilities, simulate a map for each structure in a folder. So what we need to do is to just put the input file path let's do 2MRC. You can also do the selection here, but now I will need to go to my download folder and find this file. So it can be MRC or map file. So let's hit open. It's the same thing if you as you type the path. So the structures, it does not matter if you have PDB files or MRC or CIF files. The naming here is just to say that it's structure file. And the MRC, and the output folder, let's call it identify. The threshold, let's take a look. Now it's probably too high because it looks like alpha helix, but it's not that clear. Like here it's discontinuous, so we can make it lower. Here this is a good, looks like from 0.5 to to this value, or even to 2.1. These are all a good range. So let's try something like 1.6, and we can hit run here. I am running DiffFit on a RTX 4090, so it will take only few seconds or a few tens of seconds to finish searching from these 3 structures. So now the result comes. Because we set 1.6 here, so the level here right now is shown at 1.6. And now we can see that it identifies this I7MLv6, D3 domain 3, as the top candidate, and this I7M317 domain 1 as the second top candidate. Now there are other poses which does not look very good, because this loop here does not fall into the map, and the helices are not that well aligned, even though some might look aligned. And it didn't give any placement after this thresholding for the other structure that in the library. So what's that structure in the library? Let's take a look. It's here. The third one is, I think it's this one here. Oh no, actually not this one. Probably this one, yeah. The third one is this one. Okay, so what it does, the logic is we can identify these two as the candidate that might be the structure that accounts to this density. So that's not a very big deal, because we are searching only from 3 structures. This is just for demo purposes. Now, if you want to search from the whole library as shown in the domain feed, you will need to download the whole library. We have either you generate it from it's shown either you generate it by following this guide here, the domain feed guide. I believe you will need to go from step 1 to step 3 to generate, where they have processed and then generated 344 PDB files. And while we tried to reproduce these steps, and we generated 359 PDB files. So if you don't want to go through the whole process just to take those files, you can go to our OSF repository here, and I have also mentioned the link at the documentation page at here. This is a link where if you click, it will automatically download the files. Zip file, let's save it here, and then unzip it. This file has all the structure files from this search library, where 359 structures are there. Now the task becomes rather challenging. So what we need to do is we need to simulate a map file for each of this structure. We're gonna use this functionality here, and that's the output folder, the first the first path. So we would put MRC here, and then the input structures are here, and we can use the default resolution. Or if you are really keen to match the resolution of your map, you can use that value, but 5.0 or somewhere between 4 to 6 is a good range to simulate the volumes. Now the program is simulating the volumes. Now it's 57, 66, so it will take a while to finish. Okay, it looks like it's all finished. To verify that, we come here, 359 items. That's good. So we are gonna put this as our structures simulate map structures folder is this here, but change the last 3 characters to CIF. And we save the result there again, and now we can, let's try another threshold 1.8. It's fine to use 1.6. I just want to show that DiffFit is robust against the surface level threshold. So let's hit run. With RTX 4090, it takes around 7 minutes to finish, 7 to 8 minutes to finish the whole search. And let's wait for the result. While we are waiting for the result, if you are curious, you can navigate to the output folder, which is on your working directory, which is the desktop by default. DiffFit out, identify. So here there are 2 files. This MPZ files is compressed Python's NumPy file, and there's the other one, log. It is a text file. You can open it by text editor, like Notepad, but I usually open it with VS Code. So what it shows is a log. So this is the it's adding on top of the existing file. So at 9:25, it's about 10 minutes ago, we fitted. We performed a search from this folder, which is the folder containing only 3 structures. So that's all the information, all the input information, and the optimization, and the time that it takes, and the top fits metric. And now at 2 minutes ago, we started another round of the search. So you can see here the input structures path is here, which is the path containing 359 structures, and here the optimization. You can see that the 61 iteration just popped up. So by default we are using 201 iteration. So we will need to wait for about 3 and 4 more folds of the current time, so which is around 8 minutes. So okay, now the whole computation has finished. It takes around 7.5 minutes. Let's go to the result. So we can see that it identifies again the same molecule, and the structure is well aligned with the density, except this high overhang here. And then for the second one, now you can see that this is still actually the first one, but it's just slightly, oh no, it's different. Now these two are slightly shifted, but they are, if we increase the clustering threshold, it will be grouped into one cluster. And then we can take a look at the other one here. This is with 1 hit, This is with the same ID of the first hit. It's slightly shifted. Well, this one is some helices are well aligned, while others are not. So we can see that DiffFit is quite effective in identifying the unknown densities. That's it. Thank you.